There are four different ways of using the symbol equals that we're going to pay special attention to in this class. All of these mean something very similar, but subtly different. Now, two of the uses we've mentioned explicitly already. The first use that we talked about is to state an identity. That is, to say that two expressions are equal no matter what. That is, to say that two expressions are equivalent. Some examples of this? The equation that we get when we combine like terms. 2x plus 3x equals 5x. That means those are equal no matter what x is. Now, the regular use of equals that we're used to from arithmetic, that's also an identity. Those two are also equal, no matter what. The second use of the equals sign that we've met is in stating a formula. That is, telling us about a fact about the world, that the quantities described by two expressions are equal. So, for example, the area of a rectangle with width W and length L is given by the formula A equals L times W. Now, obviously, it's not true that when I multiply any two numbers together, I get any particular third number. Right? This equation might be true or false depending on the values of the variables. But the formula tells us that this is always true as long as A is the area of some rectangle, W is its width, and L is its length. There's a third way of using equals signs that we've used but not described explicitly. We've used the equals sign to make a definition. Here's an example of the place that we've used this. When we say to evaluate the expression x squared minus x, when x equals 4, this equals sign is making a definition. This equals sign tells us what the symbol x represents. In a different problem, we might make a different definition, but as long as we're working in this same problem, everywhere we see an x, it stands in for the number 4. So when we go to evaluate this, we replace every occurrence of x with 4, and we get the number 12. Okay, so those three meanings of equals: stating an identity, stating a formula, and making a definition are the three meanings of equals that we've encountered so far. There's a fourth meaning of equals that we're going to use an awful lot coming up, and it's this: giving a fact that we want to have be true in solving a problem. So, for example, we might be trying to solve this problem. Find a number that, when we double it, gives us 10. One way we might solve this problem using algebra is call the number x. We want to have 2x equal 10. Now, at the moment we can probably guess what value of x will work here. We can probably guess that x equals 5 will work here. And the work of finding all of the x's that work in an equation like this is going to be a big part of what we do for the rest of the semester. But this kind of equation is the kind of equation that we see the most often in algebra, and there's a special verb that we have in conjunction with this kind of an equation. When we have an equation that might be true, depending on the value of the variables, We call the process of finding all such values solving the equation. The values that make the equation true are called solutions. So notice this verb to solve is a very specific verb with a very specific meaning. It means, here I have an equation that may or may not be true. Find all of the values of the variables that make the equation true. That means that if we don't have an equation, it doesn't make sense to solve. Solve is something that you can only do to an equation. It doesn't make sense to solve an expression. We can evaluate an expression, and that's typically what we do. We can also simplify an expression, but we can't solve it. Similarly, when we have an equation, we can simplify the expressions on either side, but we cannot simplify the equation itself. Now, if two equations have exactly the same solutions, that means if I give you values of the variable, either they're both true or they're both false, then we say that those equations are equivalent. Just as we have a bunch of rules for finding equivalent expressions, we have several rules for finding equivalent equations. Before we get down to the business of solving equations, we need to think about how we're going to get equivalent equations.